Good day, everyone. Welcome to our first online session on Ansys. So, in today's class, we are going to be talking about the Ansys software, where I will introduce you to the Ansys workbench. We'll talk about the software overview, how to set up a simulation, talk about 2D, 3D meshing, and also carry out a 2D analysis. So, for our learning objectives, after completing this lesson, you should be able to navigate the Ansys Workbench interface, then launch and use Ansys Mechanical. Then you know how to select the engineering data or materials, import an existing geometry in SpaceClaim. So if we have time to talk about the SpaceClaim software. So create and modify your mesh data, then impute boundary conditions. Okay, then know how to run your analysis and generate your results. So why I said we'll talk about this space claim, well, if we have time, is because this space claim is a card embedded card software. That is a software that you can use to create a card model or a geometry or modify an existing geometry. So SpaceClaim is one of those card softwares that are embedded in Ansys. Okay, in our live session, I told you that you cannot download a single Ansys software from their website. So it has to come, it always comes in the package. You have to download the entire package where you have access to all your analysis softwares. Okay, SpaceClaim is one of those softwares. So you have to, when you download the Ansys, you download the entire package. You can't download them individually. But when you are done downloading them, you can open them individually and use them. Use the one you want, or you can also go through the Ansys workbench to set up a project or analysis. So why we have other CAD embedded softwares in Ansys, SpaceClaim is one of them, and SpaceClaim is the one we'll be using for this our online session. Okay, so let me open up my Ansys workbench. Okay, this is the workbench interface. This is the workbench interface. At the top right, at the top here, you have your main menu, while just below it you have the standard toolbox. Okay, while at the left hand side, let's minimize this. Okay, yeah, so at the left hand side we have your toolbox, your analysis toolbox. Here you have your analysis toolbox. You also have the component systems. Okay, if you want to deal on individual components. This, for instance, we have our static structural analysis active and fixed in our project schematic. So this entire white space, open white space here, is what we call the project schematic. This is where you set up your analysis, and you can run more than one analysis or couple one to another. Okay, so this is your analysis system. Any analysis you want to run is available here. You have the like the one we have active currently, the static structural. If you want to carry out a structural analysis at an instant in time, you use the static structural. The same thing with steady state thermal. You want to run a steady state thermal analysis at an instant in time. In every 1 second, you use the steady state. While you have transient, okay, you have transient structural and transient thermal. If you want to run it when the time trying to run analysis with a change in time, okay, the change in time, you have to use transient. So we also have the fluid flow analysis for using CFX or using ANSYS Fluent. All right, we also have coupled harmonic analysis. We have LS Dyna if you want to carry out a crash test analysis. Okay, you have all the analysis. You have random vibration and response spectrum. You have your modal analysis. So you have so many of this analysis system that you can just you can easily set up in your project schematic and run your analysis. As I say, Fusion Ansys, you cannot download same individual one of them. Like in Ansys, you cannot download just CFS or Fluent or static structure. You have to download the entire package, and and then when you've done downloading the entire package, you want to open any of them, you can do that by going to your start menu here and then access the ANSYS 2020. ANSYS, my own version is ANSYS 2023 ROI. So you can scroll down to any of them that you want to like and you want to open. So you have the ChemChem, you have the CFS that is for fluid flow analysis. You have your ANSYS Discovery, which is another type of ANSYS Discovery is another card embedded software in ANSYS. You have your Fluent for fluid flow analysis also. You have your mechanical for your finite element analysis, which is what we'll be using in our in our in today's session. Okay, so you can open any of them individually. That is after you are done downloading. You also have the space clamp for CAD geometry. And if you scroll down, you can see your ANSYS workbench. Okay, ANSYS workbench 2023. Mine is 2023. Yours might be the upgraded version 2024 or 2025. Okay, so this is so you can now open them from here, or you can open any of the system individually. So how do you now set up this analysis system? It's a very simple process. Currently, in today's class, we'll be talking about a structural analysis. So, and how do you set up that? You scroll down to the this analysis you want to set up. Currently, we have our static structural highlighted. So, in order to set up this, all you have to do is just drag and drop in your project schematic. When you drag and move into the project schematic, you have two sides highlighted. You can have an empty box highlighted when you can easily just drop the analysis on and wait for it to load. Okay, if your system is much more powerful, it will load faster. All right, so you can just easily drag and drop. Okay, when you highlight, you can't drop it on an empty space. You have to drop it in the highlighted box or the standard in a standalone highlighted box or in an existing analysis system. So you can couple it by adding it to an existing one is called coupling. Okay, but if you put it here, if you put it in a standalone box, you are trying to create a new analysis system. So you can create a new one by dragging and drop on a standalone analysis system, and it will create a new one for you. And but you can also drag and drop on an existing analysis system and couple it to this one. So I'll drag and drop on top this one. You can see it is now coupled. So any data that I generated here will be used to carry out this analysis. That's the essence of coupling. So rather than you might decide to you have done a static structural, that is a stress analysis here. In a static structural stress analysis, you want to use the stress result in this structural analysis to carry out a thermal analysis. You want to indicate how this the stress that you generated here affects the thermal distribution in that body. You can go to your steady state thermal, just right under the static structural and couple it to this particular static structure on top this one. It's going to couple. So all the stress result that was generated here will be used to run your thermal analysis. So it isn't much that you have to couple the same type of analysis. You can couple other analysis to this. Like when you are doing your modal analysis, you have to carry out a structural analysis before you do modal. So you have to, if you want to run a modal analysis, you will run a static structural, then you will now drag the modal analysis on and add to it. So that's how you can couple any kind of analysis you want. You can set up a structural analysis and couple the fluent one to it. So that's one of the ways you can do that. So this is how you set up your analysis systems. So I will quickly delete the ones we don't need. Okay, how do you delete that? You go to the arrow at the top. Okay, click on the arrow and it will bring out this menu here. I'll click on delete. Scroll down to delete, click on delete, say okay. So I'll delete them one after the other. I'll delete them one after the other. Mhm. Okay, so we're going to be okay with this one. All right, so currently our engineering data is already has a check button. This good check button means that a value has been added. Like in this one, we have check button in both the engineering data and the geometry, signifying that we've added there is already an engineering data selected. That is, by engineering data we are talking about the materials. So we are saying it's telling us that the material has been selected and the geometry has been selected. But when you have a question mark, it means that no parameter has been assigned. So in this sequence static structure, a material has been selected and a geometry has not been selected. So we have to now select a geometry for this. But first of all, by default, whenever you open any analysis, you notice that the engineering data is already checked. So if Ansys um, by default assigns a structural steel material to your analysis, so you can decide to change that. How do you do that? You double click on it. You double click on the engineering data. It will open up the engineering data dialog box. Okay. Okay, so currently, how do you now we are at filter engineering data. So what do? You want to select new materials. You click on rather than okay, this we have two but we have two options here and they look similar, but they are not the same. They are not the same. So when you click on your engineering data, whenever you click on your engineering data, you open by default it will open the filter engineering data. This is the materials that has been selected in your analysis. Okay, so I want to change that. I will click on the engineering data sources. Okay, that is you want to open up the sources. You want to select materials for your analysis. So I will click on under the engineering data sources. I'll click on the ANSYS materials. ANSYS material or general materials. You have several materials library here that you can select from. So wait for it to load. My Fusion is my ANSYS, my software is lagging a little bit. So we're going to wait for it to load. So you might notice this in your own if you're not using a very powerful software. Okay, you might notice some lag on your whenever you are operating. So just make sure you're a little bit patient. You are going to okay, I can't find anything under this. Let's try another material. Okay. Just like I said in our live class that there is an issue with my own software. Okay, so when you notice when I click on the additive manufacturing material library, it opens up the library here outline of all the materials under additive manufacturing here. Why this one is the properties. Okay, so the issue is that under the material name, okay, rather than giving us the name of the material, it will retain this library name, which is additive manufacturing materials. We can't really tell which of the material that is being displayed, and how the only way we can tell is by clicking on any of them and at the and this and on the properties tab, just at the top of the properties tab, you can see the name here. Okay, currently this is COCR additive material. So that's the only way I can know the type of the material that I selected. Now it has changed. Okay, you can see that. Right. So I'm going to use, I don't want to use additive material, I'll use on general materials. We're also going to encounter the same issue. I don't know why I'm having that problem on my own end, but you will not going you on your own it will be better. I believe that this issue uh, might not repeat in your own software, or your own software will have a different result. Okay, so we also have the same issue here. Have general materials all true. Okay, but in your own case, when you click on the general materials, you're going to come up with the names of the material, not the what you will be seeing here is like you'll be seeing cast iron, aluminium, not general materials. So yours will retain the actual name of those materials. So if I want to know the type of materials that are selected here, I'll click on this and you can see first material is air, second general material is aluminium alloy. Okay, I want to add aluminium alloy. I will click on this plus sign here to add it to our engineering data. Okay, I'll click on the plus sign and the book will be placed beside it. This book beside it will be showing you that it has been added to your material library. So I will click it, I will scroll down and select another material. I've added aluminum alloy. I want to add another one. Now this second one is concrete, just you can see it here. Then this is copper alloy. So I will click on the plus sign because I want to add copper alloy to my library, my data library. So the library has been added. So I've added two material. I've added two material to my engineering data. Okay, so I'll go to my engineering at the standard toolbar and cancel this engineering data. Just click on this X here to move away from this data. You just know that once you click on plus, it has been added, so you don't need to worry about this. Okay, and I go cancel. Our data has been added to our copper alloy and aluminum alloy. So the next thing is to add your geometry. So how do you add geometry? You can right click on this on the geometry tab, okay, and import an existing geometry. So in this case, we are going to import from our library. All right. So remember, I told you that we have some CAD softwares that are embedded in Ansys. You can use this CAD software to design new model or to modify an existing one. So you can design in another software. You are conversant with Fusion 360. You are conversant with Inventor, SolidWorks. Okay, you design your model in SolidWorks software. You can import it here. So Ansys accepts a lot of file formats. Okay, a lot of CAD file formats. So you can design them in those softwares, then import it into Ansys using this browse button. You can import it from your library. Okay, but you also have three CAD softwares here that you can design from. Okay, you can use Discovery to design your one. You can use SpaceClaim to design. You can use Design Modeler to design a new model. Okay, but if you want to modify for your analysis, you can import from other sources and also modify in any of these three. So it gives you the option to either design or modify your existing models. Okay, so I will click on the browser I want to add from my library. So this is the material I want to use. This is step 5. Okay, I'll select this and click open. So you can see the check mark button has been added. So yes, the check mark button has been added. So we have our model inserted for us. So if I right click now, and let's say I want to modify this, you can see edit. It's no longer create now, but edit. It's no longer new geometry or new geometry. It's now edit geometry in Discovery. You can open them in any of these CAD softwares, any of these softwares to modify them. So I'm okay with that. Then you can now double click on this to open your mechanical. So if you double click on this, you're going to open up your mechanical environment. All right. So I'm going to do that and open up my mechanical. So when you can either you can either double click or if you right click, you will see the edit. So if I should click on edit now, it's going to open up my Ansys mechanical. So I'm going to quickly open up mine. Okay, so this is my model. My model have been inserted, but in my geometry tab, I'm still having this question mark. So you might be wondering, why am I having this question mark here when I've already inserted the geometry? That's because this is a 2D analysis, like I said in our live class, that we are going to run a simple 2D analysis. So by a 2D body that has not gotten a thickness here. This is an existing geometry, but it doesn't have a thickness. So we are going to add a thickness to make it more realistic. Okay, you cannot run an analysis on a body that has no thickness. So it's not real. When a body doesn't have any existing thickness, no matter how little it is, then that body is like should I say an it's not a real body. It's an ID body, but it's not a real body. It doesn't exist. Okay, it has no existing thickness. So we are going to add a thickness. And how do we do that? I'll click on this. Whenever you highlight, click to highlight any particular option in your project schematic. The details of that option will be displayed here. Okay, so you can see our thickness is highlighted yellow, meaning that there is no value for thickness, 0 millimeter. So this model doesn't really exist. All right, so we are going to add a thickness and say millimeter and press enter. You can see the good check button, check mark icon has been added to our geometry. So the next thing we'll do is the material. Currently, if I should click on the material, we have our structural steel. Okay, I did not add the structural steel to this one. I didn't add the engineering data to this one, but we'll be working in this session. We'll be working with just structural steel. Okay, in our next class, we'll talk about how to change that. Okay, or how to select other materials. So next thing we'll do is to go to our mesh tab. Okay, by default, if you remember, I said if you want to view the details of any option in our project schematic, just left click to highlight, select that one. The details will be displayed here. All right. So the two things I want you to pay attention to is the element size and the statistics. Okay. So these are the two things I want you to pay attention to. This element size in this our first class, the two things you should pay attention to is this element size and this our statistics, the nodes and the elements. Okay, that is what we should pay more attention to. All right, for our element size is 124.51 millimeter. So I'm going to say, okay, I'm okay with this. Let me generate this image. Let's generate a mesh using this. So how do you do that? Left click to select your material, to select the option, the mesh option in your project schematic. You right click and you have the option to, the third option there is generate mesh. So click on generate mesh and wait for it to generate. At the bottom here, bottom left corner, you see it generating. You see your, okay, at this bottom, you see the mesh generating. Okay, now our mesh has been generated. Okay, but if you look at this is not a well refined mesh or a fine mesh here. So, but it doesn't matter. In our advanced classes, I'll teach you how to talk about, we'll dive deep into mesh in our hand to refine a better mesh. Okay, so I want to talk about how um, re- refinement. I want to remind and let you know that your mesh refinement affects the quality of your result. If you don't have a fine mesh on this your body and your geometry, your result it will generate a result for you, but the result might not be as accurate as you want. The result might not be accurate or might not represent a real size a real life solution. So if I should scroll down to this, we have the note. Our default element size was 124 millimeter, and our notes is 200 notes. Notes is this. Let me select point. Okay, this is a node selector. Okay, this is vectors. Yeah, your node is this node here. Okay, this node here, and you have a node in between also. Don't know why it's not selecting. You have a node in between each element. So let's show you how to select not an element selector. Okay, element. This is an element. Okay, each of these is an element. Each box you are seeing here is an element. Some of them are triangular. Okay, I can't find any triangular here. This is a quad mesh. Okay, this is a triangular mesh here. This is an element, triangular element. This is a quad element. Okay, all these are elements. This that I'm selecting an element. So you have your node. Okay, this is your node. The point between where one or more elements meet is called the node. Okay, so it uses this to tell you the parameters of your mesh data. So you have 200 nodes. You have 200 nodes currently in this model, in this geometry, and we have 179 elements. So if you count this now, it will give you 179. So this is the data we had from our this is the data we had from excuse me. No, all right, let's continue. This is the data we had from our element size of 124 millimeter. Okay, so but before we proceed, we are going to I want to show you how to use how to navigate this. You can see I can move this in space. I can also pan it around. I can also pan it in two direction. All right. So how do you do this? So you have the zoom button. You can use your scroll button on your mouse to zoom. So, but if your mouse doesn't have the scroll button, you have the zoom um, icon here. You have two different type of zoom. You have the box zoom where you can can drag and drop to zoom on that particular section. Okay. So if I want to zoom on this hole at the center, I can to draw a square and zoom at it. Okay. So how do you use the other option for zoom? Okay. Once you click on the second zoom option, so just hold down your left mouse button and drag up and drag down to zoom in. Okay. That's if you don't have the scroll button on your mouse. But if you have the scroll button on your mouse, you can just use your scroll button to zoom in and zoom out. All right. You also have the next one is the pan. Pan is to move it in X and Y direction. So when you click on the pan, you can hold down your left mouse button and move it in any X and Y direction that you want. Okay. But there's another way to do this. And how do you do carry out a pan without using this? You can do that by holding your control or your command on your keyboard, holding down the control. Then you hold down the scroll button on your mouse. When you hold down the scroll button on your mouse, you can drag and move it in any direction you want. So control or command plus scroll button to you hold down the scroll button and you move. So the next one is the orbit. Okay, if I should select the orbit, hold down your left mouse button, you can move it in space, okay, in any direction. Okay, this is what we call the orbit. Okay, you also have another option. How do you do this without using this option, this rotate at the top here? How do you at the toolbar here? How do you do that? Just hold down your scroll button and scroll. This time around, you will not hold down the control or command on your keyboard. Just the scroll button enough. Just hold it, press it down, and move in any direction you want. Okay. But if I should hold down the control or command button and hold down my scroll button, it is going to turn to pan. Okay, so that is one of the ways you can move your design. So if you are dealing with complex geometry, you might want to move around and apply boundary condition on other edges. All right, so I'm okay with this. The next thing we are going to do, is to add our boundary conditions. Okay, so first of all, we're going to work with this and generate the results, and then refine our mesh and use a proper refined mesh and compare both results. So for my static structure, how do you add boundary condition? Go to the static structure, all right. Then I will right click and insert a fixed support. I'm going to insert a fixed support. Okay, I'm going to cancel this. I don't want this now. Okay, I'm going to insert a fixed support. So currently we have to apply the geometry for the where do you want to fix the support? So I want to fix the support in this direction. I want to add a fixed support here. I want to add a fixed support here. I want to fix this in space. I want to fix this side in space and then apply a stress in this direction. I want to apply a stress in this. I'm going to apply a force or load in this direction. Okay, so when I fix this area and apply a 500 Newton force in this direction, I will see how this force causes stress or displacement on this body with respect to this fixed edge. So this is what we are going to do. All right, so for the geometry, I'm going to select this edge. Okay, so but currently, how do you select it? You have the box selectors here. I've shown you how to use this. I've shown you how to use this to select your this to select your node, to select your element. Okay, you also have other box to select body. Okay, so this is a 2D body. That's why this body selector is not highlighted. So the next one is the face selector. So you can use it to select the face, the entire face of your body. But this face is not what we want. We only want the edge. So you also have the edge selector. You have the vectors. Vectors is to select the vectors of this body, but that is not what we want. So we want edge selector. Want to select this particular edge. So I will say use the edge selector. Hover around it, you see the particular selector currently is edge. Next one is face. Okay, this one is vectors. Right, this one is body. Right, so we are going to use the edge selector. I'll select the edge. Then we'll click on apply. So you can see there is a check mark button on our fix support telling us that we've fixed this edge. So the next thing we are going to add I'll go to I will right click on my static structural and click on insert and go to insert. And when I hover around insert, it will open up this. There are so many boundary conditions that you can apply. You can scroll down. There are so many. Okay, use this scroll bar. You can scroll down. I will go up again. There are so many. Okay, but in this case, I want to be using force. I'm going to apply a force to that direction. So you can see my force here. My force here is having a question mark, meaning I've not added force. We're going to add force to this edge. So I'll select the edge. Okay, when I select the edge, I'll click on apply. All right. Okay, but we are not sure of the direction of that force. Remember, I told you we want to add this force in this direction. Okay, we want it to be in this direction, not the opposite. All right, and not in the vertical direction also. Okay, not in the vertical direction. Okay, so we want it to only be in this direction. All right, so we have to make sure we are using the right parameters. So I will go to the next thing we will do under our dialog box is to add the magnitude. So like I told you, magnitude is 500 Newton, 500 Newton, and press enter. So currently, you can see from the arrow pointed here that currently the direction is placed downwards in the vertical direction, which is not what we want. We want it to be placed in the horizontal direction facing our right hand side. Okay, so we are going to go to the next option there, just under the magnitude, and click on change direction. So I'm going to click on this change direction and apply. I want it to be in the horizontal. I want it to be in this horizontal direction. So I'm going to select an horizontal edge to make sure it places it there. So currently, you can see that it has placed it in this horizontal direction. It has placed it in a horizontal direction, but it's still facing the other side. So how do you change that? You use this box here. There's a box here for you to change the direction. So use this box here to click on it. Click on this side. Currently, this side is highlighted, meaning that it's facing here. So we are going to click on this side. So if I should click on this, you can see it has changed direction. So it has changed the direction now. So you can see, don't worry about it placed under here. Since we selected this edge during the geometry selection, we move it to the side. So this is just an illustration showing the direction of where our force would be. So when I click apply, as after you have to select all those parameters before you click on apply to change. Okay, so you can see our direction has been added in the appropriate place. Let me repeat this one more time for those of you that didn't follow. So I'll delete it, and you see, do you want to delete? Yes, and you can delete any boundary condition that you added. So I'll right click and say insert, then I insert force. So apply the force this direction, this edge, say okay. Then magnitude 500 Newton, enter. So I want to change the direction, click on direction. I want it to be in the horizontal, and the next change in the opposite direction. And I'll click on apply. Okay, now it has been added for us just the way we want. Okay, so the next thing we will do is to add what result do we want to view. So you can go ahead and run the analysis now, then attach result later. But you can also attach the result you want to view. So in this case, we only want to view the stress result. So I'm going to go to right click on my solution. The same way you right click on your static structurer, you can also right click on the solution. This is the solution we want to view. I want to view my stress. Okay, so you have several options for stress. You have equivalent, maximum. Okay, so but in this case, I want to view the equivalent stress. So I'm okay with this. So we are done with selecting our boundary conditions. So how do you solve this? You can right click on this on the solution and go to solve, or you have the solve at the top here, the top of your toolbar. You click on solve, it will start solving. So if I should click on solve, look, watch at the bottom layer, you can see it will start solving and it will show here. Currently it's at 6%. Wait for it to solve. So your mesh data we determine the speed at which it solves. So if you have more mesh elements and node, like I showed you initially, that we had 200 node 179 elements. So if you have more elements, let's say you have 20,000 nodes and elements, it will take more time for you to solve. So the lesser number of nodes and elements, the lesser time it will take for you to solve your data. But the better, higher number of nodes and elements, the more accurate your result, or rather, the more refined your mesh data, the more accurate your result will be. So currently it's at 85%. We'll wait for it to complete the calculation. Okay, so our solution is ready. You can see the good check mark button. So if you should go back to your workbench, you can see there's a good we have a check mark button, because this is the analysis we are running. We've not really done this. Okay, I only use this to show you how to add your geometry and your engineering data, and how to open up your Ansys mechanical. So you can see there's a good check mark button in all of them, telling us that every data has been generated, all our results has been generated. So how do you view the result now? So if you want to view the result, you go to the equivalent stress that we added and you left click. Okay, you can view our results. Okay, we have a maximum stress of 1.312 megapascal. That is the maximum shear stress, and it's located at this whole region. Both the maximum and the minimum is located at this whole region here, the region of maximum stress and the region of minimum stress. So you can pinpoint this. So if you're trying to identify where you have this maximum and where you have the minimum, you can use this probe button here. Click on the maximum, it will place it for you. Okay, when you click on the minimum, also it will snap to the minimum. Okay, so when you zoom, you can see the region of maximum stress 1.39, region of minimum stress. So this is the result of your stress result of your analysis. This is the stress distribution of your analysis. So if you are trying to remember, I told you that we are going to refine the mesh and compare the accuracy of both results. You can see the results, you have 1.39, 1.31 megapascal. So if you should go ahead and use this result, thinking that you have you've gotten the actual real life value or real life stress value of this body, that you are okay to go, you might end up having a wrong an error somewhere, or a wrong data of what the real life stress value of this body would be. So let's go back and refine our mesh and see if the mesh refinement affects the result that we are going to get. Currently we have 1.3, okay, 1.31 megapascal. So we are going to go back to our mesh data. I'll click on the mesh data, and either you can just go ahead and change the element size, or you can clear this data. You can go ahead and change the element size without clearing this one. You can also clear the data by saying clear generated mesh data. So I'll clear it. Yes, I'll clear the data. It will be wiped up. You have a clean slate. So, but if you don't want to clear it, you can still go ahead and just change your element size and continue running your analysis. Okay, it doesn't matter. So I will go to this and select 20 millimeter. Remember, initially it was 124, but this time select 20 millimeter. And now let's view our nodes and elements. Okay. Currently, I've changed the element size. You need to generate. I just added the element size. We need to generate. You can see there's nothing in our node and element telling us that, showing us that we've not generated the mesh. So when you change your element, you have to generate the mesh again. So I'll click on generate mesh. The same way, even if you didn't clear the data, you can, even if you don't clear the initial mesh data, when you change your element size, you have to generate the mesh. So you always have to generate mesh anytime you change any parameter in your mesh data. So this is what we call this mesh data is what we call our global setting. So in our live class, we talked about the global and local settings. Okay, this is your global setting. This is your local setting. Your local setting was discussed in the live session. Okay, so we can see we now have a better final mesh and more refined mesh. Even by just looking at it, you know that this looks much more better and more refined. But when you scroll down to the nodes and elements, you have 2000. Imagine an increase from 200 to 2500, and you have element of 2484. You can see we have more nodes and elements. So this will take longer time to solve than that initial one. So that's what it means. Okay, so you can also refine this even more. I can go, I don't want to clear the data. I can right click, go to my this and change it to 15 millimeter. Click enter. Okay, you will see this color of this thing will change, telling us that it's trying to show you that a new data has been added. So we have to regenerate the mesh again. So regenerate mesh and wait for it to load. So currently it's loading. We are going to even have a more finer mesh. Okay, just be a little bit patient, because remember, the lesser the element size, the more time it will take to solve. Okay, but we don't really want that. Okay, I think I'm just gonna, this will take a lot of time to generate that mesh, so I'll cancel it. You can cancel it using this red box here, and I'll input a much more higher element size. I'll click enter 25, then I'll click on right click on mesh and say generate. Okay, this should be faster than the previous one. This should generate faster than the 15 millimeter. Okay, currently our mesh has been generated. So this is how you do. Okay, but remember, we want to compare 20 millimeter with 124. So I'm going to add 20 and say enter. Then I'll regenerate mesh again. Okay, we're going to compare our the value we had for 20 millimeter element size mesh and the one we have, the first analysis we did for 124 millimeter element size mesh. And in that one, we had 1.31 megapascal as maximum stress. Okay, we're trying to compare the stress value or the stress results. So wait for our mesh to load. Our mesh is almost done. Okay, we have this very refined mesh. Can check the node and element. We have more nodes and elements, 2000. Okay, the initial one was 200 and 179. So now let's run the analysis. I'll right click on solve and click on solve. I'll go to this top and click on the solve button here. It will start solving. When you look at it down, currently it's at 10%. Okay, wait for it to solve. Okay, depending on also the capacity of your system. The capacity of your system specification affects the rate at which Ansys solves your analysis. Okay, it's almost done. So you can see we now have entire check mark button here, so telling us that our analysis has been solved. So if I should let's click on equivalent stress, you can see that the maximum stress is 1.4. So we have a higher maximum stress here. So this value is much more accurate than the previous one. Okay, so this is how you know your mesh. This is how you can compare results. So we have a higher maximum stress here, which is 1.41 megapascal. The other one was 1.31 megapascal. So just by refining the mesh, we're able to get a better result. So this is one of the ways you can do that. Awesome. So I believe that concludes our first class, online class on Ansys Workbench and Ansys Mechanica. So um, thank you for making our time to attend today's session. In our next class, we're going to dive deep into structural analysis using Ansys Mechanica.